Well, welcome to 8.5. This is the second last lesson we're going to do. I hope you've been studying for your finals already. If not, you're probably going to have to do a lot of cramming. So in this lesson, what we're going to do is we're going to teach you how to construct and analyze a tessellation. Now, a tessellation, we have to start at the very, very beginning. So here we go. We're talking about a plane first, because we draw our tessellations on a plane. So what is a plane? Well, in terms of geometry, it's basically a large flat surface. So your desktop, that's a plane. The floor, that's a plane. Right? Now in geometry, it's basically stated as a flat two-dimensional space that has a length and a width. So it's a flat surface. Now if you look around your classroom, obviously I don't know if you're in a class or not, but if you're at home, you can look around your home. You'll probably see your tabletop, your floor. Maybe you have a desk at home, maybe the top of the bed. As I look around my classroom, I see a whiteboard, a piece of paper on the desk over here. I have scribbler pages open, and I've got the floor and the roof and the wall as the planes that I have. Okay. Now, when you put a tessellation onto a piece of paper, maybe we should just back up for a second and say, what is a tessellation? Well, a tessellation is a shape that you can draw on a piece of paper that has absolutely no gaps in it. Okay? So you can repeat it by turning it, flipping it, whatever you want, but you could make a solid pattern that would extend forever. That's what a tessellation is. So we're going to start with a couple of exercises here. So I need you to get, your teacher should give you a blank piece of manila tag, which is basically thick paper. If you're at home and you don't have one, any thick cardboard would do. You can even do it with a piece of paper if you have to, but you'll have to be very careful. All right. Now we're going to be taking this piece of paper and we're going to cut two pieces out of it. So I need you to make a hamburger fold out of it. And then I need you to cut out, or draw first, draw out an irregular quadrilateral. Can't be a rectangle. Remember, a quadrilateral is a four-sided figure. It's a polygon with four sides. Not a rectangle, okay, so that, or a square. Now, you also have to do a triangle. So I need you to take, on the top half, cut out the rectangle, and the bottom half, cut off the triangle. That's the first thing you have to do, okay? Now, once you have that done, we'll go to part one of the actual exercise. So pause the recording, and you'll have to cut these out and make them big enough that you can actually draw around them. So nothing about a centimeter tall. Make them about 5, 6, 7 centimeters tall or wide, okay? So pause the recording and do that. Okay, so we're going to do first one is a quadrilateral. Now remember, a quadrilateral is basically just well, here, you look up here. Here's our bond here. I wonder if I can find them here. Well, this is a quadrilateral here, right? And this one here is a quadrilateral, right? There's one quadrilateral. That's a square. I suppose I can take this one and make it into a rectangle, right? If I go over here, I get a whole bunch of different types of quadrilaterals. Here's a parallelogram. Here's a rhombus, okay? And these are things that they're all have, if you look at them, four sides. All right. Now you can draw any one of these, and we're going to ask you to make a tessellation out of it. Okay. So taking a look at that, I'll go back to my full screen. All right. And I want you to draw the tracing of your object or your quadrilateral in the middle of the page below where this is taking place down here. Okay. Now once you've drawn it, I need you to go to the sides and start creating a pattern. Okay. Now, let me see if I'll grab a quadrilateral here and give you an idea of what I'm talking about. All right. Well, let's go with I wonder I could use. I'll just use yeah, I'll use one of these. Okay. All right. So here's my shape that I'm going to do. All right. Now you obviously can't do this, but I'm going to turn this into a clone for myself, so I don't have to redraw it, and it'll always be exactly the same. So I need you to take this, and I need you in some way to create a pattern that will actually create no gaps. Now, if you do this here, you're not going to be able to get. Well, you might be able to get the other one in here, but this is the most common one. Take this, flip it upside down, and then you can put it beside it just like that, right? And you can grab this one, put it right here, right? Then you can grab this. I'll turn this one into a clone also. You can grab this one, and you can grab that one. And you see how I've created a pattern here? There's absolutely no gaps in here. Now, if I wanted to go down or up or sideways, I could just grab this and move it down, right? There's down, and I can grab this one and move it over, and again, I can just keep moving sideways. And you'll notice that there is no, oops, sorry, wrong one. There are no gaps, okay? I need you to do this on your page in front of you, okay? And I'll pause the recording and then do it, and then we'll see what you come up with, all right? Oops, that was a mistake. All right, well, I was going to try to reveal this to you in a real nice way, like, you know, go like this here and then slide down and say, look at mine, but I guess I opened it too early. Either way, this is a quadrilateral, and if you take a look, it's what's called a rhombus. This side here and that side here are all equal, okay? Now remember, in geometry, there is no such thing as a diamond, right? It's either a square turned on its corner or it's a rhombus, but there is no diamond, all right? Now, this is a quadrilateral, and you should have the same thing. Now, mine are black and white, or I guess this is check pattern here, but they're the exact same shape, and as I put them together, you'll notice there are no gaps anywhere. Okay, so that means this is a tessellation, and here is your object right here that you're going to be you use. Okay, so you move this one up here, move it down. You could move it over and over and over and over, and then you take one which is the same shape exactly, and you maybe color it white, and then put it here and here. Okay, now let's go down to the next one. Now we're going to do the exact same thing with a small triangle. So I need you to take and create a triangle, and it can be any type of triangle you want. It can be a right triangle. It could be a quad. No, side. What else kind of triangles we got here? We got an isosceles right here. I suppose I could spread that out to be an equilateral. Okay, and there's your isosceles. You could choose any type of these ones you want. Okay, now draw it in the middle, and then create a tessellation out of it. See if you can arrange it so there's no gaps. So pause the recording and do that. All right, so now, here is my tessellation. And you'll see that I made mine out of, really, what is a isosceles triangle here, all right? It's, I don't know if I can make this actually fit the way that they, I don't know, can I make this slide over? There you go, very close, okay? So you can see that this one here is drawn there, it's drawn here, it's drawn here and here, and then I flip it upside down and it'll go here, here, and here. So this is a tessellation using triangles. Okay. Now, if you were in the classroom and you look around, you'll find that not everybody drew the exact same type of a triangle. All right. Somebody might have drawn equilateral, some could have drawn a right, and then somebody else might have drawn what's called a scalene, which looks something like this. All right. It doesn't matter how you do it. Every single one of these is going to tessellate, right? So let's go on to the next part. So now that you, how do we figure it out if you don't cut it out and try to make the pattern? How can you figure out whether or not it tessellates? Well, it's actually fairly straightforward, okay? And it says here, right here, you can see it, if the corners of the shape can be placed together in a way that will create a multiple of 180 degrees, then the shape will tessellate. All right. Now what that means is, if I go back to my quadrilateral, all right, if I look right here at this part right there, okay, maybe I'll change the color. Let's go down here then. Okay. Now, if you look right here, you'll notice that I've got three angles here. I've got one here, okay, and I've got one here, right, and I also have one here and one here. So I've got four of them. Right? Now you notice that this here rhombus actually has four corners, doesn't it? Well, if you were to take each one of those corners and put them together, you'll notice this makes exactly 360 degrees. Okay. Now, because 360 is a multiple of 180, okay, we know that that's going to work. All right. Now, you can do this with a quadrilateral. We can also go down and we can do it with our triangle. All right. Same type of thing here. Grab a circle and take a look. I'll just try right here. Okay. You'll notice that in here, I've got the triangle angles this one and this one and this one, all right? And then I flip it to put that angle down here. Then I flip it again to put this angle in here, all right? And you notice that I make basically 180 degrees here and 180 degrees there from the other three, and this gives us a full 360 degrees. So because this makes a 360-degree angle, all right, we know that this is going to be able to tessellate. Now, there's another way to look at this too. If you look at a triangle, we know that a triangle has an angle here, here, and here. This angle, and this angle, and this angle in our laws of triangles, they have to add up to 180 degrees, right? So that means since 180 is a multiple of 180, then this is actually going to tessellate. This is why all of our triangles tessellated, because you add this angle and that angle on the scalene one here, you get 180. This right angle triangle, that one and the 90 degree there and that one there, that's 180. And of course, this equilateral 60, 60, and 60 is 180. Right? So adding these up, the interior angles, if you get a multiple of 180, then it's going to tessellate. Now let's take this and look at the one previous, where'd we go here? Got our quadrilateral. Does measuring the internal angles work? Well, I want you to imagine for a second that there is a line from here to here, right? Now, what that means is this here is a triangle, right? See that? And this here is a triangle, right? So if I had this triangle here, all right, change this to a different color. If I had this triangle here, I could just flip it over and tessellate it, right? I can do what's called a reflection, and I get the rectangle, the quadrilateral, don't I? And of course, those two triangles could be moved to here. Sorry, change colors. From to here, to here, to here, to here, to here, to here, and you will get a tessellation. Now, the thing about this is, if this is 180, and this here is 180, when you add this angle, this angle, this angle, and those two and that one, if you add these 6 angles together, you get 360 degrees, just like we showed down here. Right? So is 360 a multiple of 180? Well, it's 180 times 2. So we know that if you measure all of the angles inside your quadrilateral, they add up to 360 degrees. That means because the quadrilateral adds up to 360 and it's made of 2 triangles, each of 180, that means that all quadrilaterals, every single one of them, is going to tessellate. Right? Doesn't matter how you draw it. It can be a kite, it could be a rectangle, it could be a square, a rhombus, it could be anything that's a 4-sided figure. Okay? So, what can we conclude from all of this up here? Well, we can conclude that, simply put, all rectangles and triangles tessellate. Okay? Simple as that. All of them do. Now, moving to the next page here. If I can't cut it out, and you gave me a square, then I could take that rectangle and I could measure the 4 angles in it, right? I could measure this one, and this one, and this one, and this one, and I'm going to get 360. Because it's a quadrilateral, this tessellates, right? If I had a triangle, right, I could measure the 3 angles, this one here, and this one here, and I would get the sum of the interior angles being 180 degrees, right? So that means that this is 180, this is 180 times 2, so we know this tessellates and this tessellates. Well, what if it's not a rectangle? What if it's not a triangle? So what I have here is I have what's called a hexagon. Now, you probably think of hexagons as being something, this is your regular hexagon that you think about, right? Now, a hexagon is defined as 6 sides. So 1, 2, 3, 4, 5, 6. If you look over here, I've got 1, 2, 3, 4, 5, 6. This is what's referred to as a regular hexagon. All the angles and all the sides are all equal. Over here, this is what's referred to as an irregular hexagon. That means that not all the angles are equal, right? And not all the side lengths are equal. For example, this side right there is not the same as this. This is a 270 degree and this is a 90. So we basically do not have the same angles or the same lengths. So this is irregular. Okay, now we go. Get back here. If you take a look at this shape right here, right, and you know this is a 90, this is a 90, and this here is a 90 on this side. That means this outside, because this is a full circle, has to be 270, and I showed you right here. Here's your 90. That means that's got to be 270, right? Now, if I take the 90 and the 270 and I put them together, I get the full circle, right? If I look at this shape right here, all right, you'll notice if I put this, and this, the different ends of the hexagon together, I get 490s. That also makes 360. All right. So this shape right here, because it's the way it is, it tessellates. Now the question is, do all hexagons tessellate? And no. That's not, they don't, okay? I'll give you a real quick example here. I don't know if I can draw one quickly, but if I had a hexagon that looked like this, there's your two sides, right? 3, 4, 5, 6. There's no way this shape can slide into here. So that means that not all hexagons will actually tessellate, right? So you have to be careful. Don't just assume it. Now, let's go on down to this one here. This is a triangle. You can see that it's got three angles, a 39 degree down here. And I've got a 75 and a 66 up here. Kind of, this is 75, that's a 66. And I've taken the 39 and the 39 and the 260, I've created a full circle, right? Now, this 39, 75, these all add up to make the full circle of 360 degrees. Means acute triangle, this acute triangle will tessellate. And we go over and look at this one. I've got this is an obtuse triangle. You can see that the angle here is greater than 90. So that means that even if you do, I've got 19, 110, and 51, you put them all together and you get 360. So even by checking with the angles and putting them all together, if you add up the interior angles and it becomes a multiple of 180, then you know it tessellates. Now I'm kind of overdone this because I've done the tessellation and shown you that it adds the 360, but we know that the interior angles of a triangle, 66, 75, and 39, they equal 180 degrees, right? So having done that, you go over here, this triangle is the same way. It also equals 180 degrees. So we know that all triangles tessellate. So summation, all triangles tessellate, doesn't matter what kind they are. All quadrilateral four-sided figures, they all tessellate, no matter what they are. Now, pentagons, there's a type of pentagon that will tessellate, but there's many that don't. Hexagons, there are types of hexagons that tessellate, and there are many that don't. So you have to be very careful with those. Okay, so here's a quadrilateral. I've given you two types of quadrilaterals here, just to prove to you that even if you have a quadrilateral which is not a square or a rectangle, and you just drew it, then you can make sure that because it's got four sides, it will actually tessellate. So I did what's called a convex quadrilateral. Now, if you remember way back, convex and concave. Convex means that all the angles are out pointing, all right? And a concave means that you could actually, and I don't remember if I told you this, but I did, this is an example that I used, right? You had something like this. Sorry, I guess arrows rather. But if you look at this, you could walk into the cave. Remember that from last year? If you can walk into the cave, then it's a concave. If you can't walk into a cave, then it's a convex. So I've got two different types of quadrilaterals here. But because they have four sides, they also make a 360 degree. And this one over here also makes 360. Okay? So this proves that adds 360 and that adds 360. So do these two polygons tessellate? Yes, they do. All right? They both tessellate. So here's proof. Quadrilaterals all tessellate, and previous page was triangles. Okay, so now what I want you to do is I want you to create a convex quadrilateral. And remember that all the points point out, so this is the convex, you want to make something like this, and I want you to draw a tessellation with your quadrilateral. Now, you could make it any shapes you want, but remember, it must be convex. So pause the what do you want to call it? The video, and draw your shape here with a convex quadrilateral to prove that it does in fact tessellate. So pause the video and do that. Okay, so here's my quadrilateral, and I have measured my angles. Okay, because I'm going to do it without actually trying to find it. So I've got 73, I've got a 103, a 119, and if I add these all up, guess what they add up to? 360 degrees. So this is a four-sided figure. All my interior angles add up to be a multiple of 180, which is basically 360. It's the second multiple of 180. So that means that this here quadrilateral does in fact tessellate. Now you notice we can do that without actually having to draw it. Right? You just have to be able to measure the angles. Going to the next one. Okay. Now I want you to do a concave quadrilateral. All right. I want you to draw it big enough, and I want you to measure the angles. So pause the recording and do that, and see if you get 360 on your quadrilateral, which is concave. So pause it and do that right now. All right, concave. Remember concave, you walk into it. So here's my concave. You walk into it. Now I measured, this is 38, this is 20, this is 269. Remember, you have to do the inside angle. So this is greater than 180, so this is what we call a reflex angle. And over here I have 33. If I take the 38, the 269, the 20, and the 33 and add them all up, I get 360. Now, if you were in my class, I would say, okay, who didn't get 360? And a bunch of you would have put your hands up. Because what happens is the thickness of the line, right? And where this point is here with your protractor, you put your protractor on just in the wrong way. Let's see if I can just show you what I mean by here. Okay, so if you were to put that there, right, and then you could take and you could move this to where this angle is, and then you could move up and you'd find that this is actually 38 degrees, right? But what happens if the protractor wasn't exactly on this dot, right? So now you'll notice that I'm not 38, I'm now, well, actually still 38, but what if it was, sorry, I'll make it just as big. What if you went sideways? See how it changes if you're not perfect? Right? That's one error you can make. The second one is, what happens if your lines aren't, nice and thin? What if your pencil sharpener wasn't very, your pencil wasn't very sharp? Now, where do you measure the line when you put your protractor on it here, right? These are the things that cause errors for you. Okay, so if you do this exercise and you find that you don't get 360, it's not because the law has been broken. It's because the way you drew it, the way you measured it, all right, you have a slight error in your measurements. And when you add them all up, you might get 361, you might get 362, you might get 358 or 359. Right? Hopefully you'll get 360. But if you don't worry about it. It's not because things didn't work out. Okay? So this happens to be 360 is a multiple of 180. Because remember, the multiples of 180 are 180, and then after that comes 360, and then comes 540, and then 720. So 360 is a multiple of 180, so this actually works. Okay? Now I want you to draw a triangle large enough to measure its angles. So we're going to have you do this without cutting it out and trying to trace around it. So draw a very large triangle. Doesn't matter what kind it is. It can be acute, it can be obtuse, it could be scalene, whatever you want to do. Okay, and measure its internal angles and mark them down, and then add them up and see if you get the proper number. So do that right now. Okay, so here's my triangle that I drew. It's a obtuse triangle with 108. Remember, obtuse triangles are angles which are triangles that have an angle which is more than 90. Okay, that makes it obtuse. Of course, if this is 108 and that's 45 and that's 27, you add those all together and you get 180 degrees. Now, if you drew this and you didn't get 180, you get 179, then it's just because there's a slight variance in your measuring. Now, to determine if it tessellates, it's got to be a multiple of 180. So since the interior angles here add up to be a multiple of 180, it's the first one, right? This is written wrong. It should be a multiple of 180, not 360. Okay, so just ignore that for a second here. This was written wrong. It should be 180. Oops, ran off my mouse pad there. There we go. Okay, if it's 180 degrees, then it tessellates. All right, going on to the next one. You should now have done tessellations by drawing triangles and copying them out to try to make a pattern. You've also done triangles by measuring the internal angles. You've also done rectangles or quadrilaterals by drawing them out and creating a pattern with no gaps. And you also measured the interior angles, and you found out that they make 360, and we know that that tessellates. So your conclusion should be that every triangle, every rectangle, they always tessellate. Doesn't matter what kind they are, right? It could be any type of a rectangle, sorry, any type of a quadrilateral. Right? This here should say rectangle, this should say quadrilateral there. Okay, so I don't know if I can, I'm not gonna worry about it. This should be quadrilateral, so mark your notes, change them. All right, and this here should say quadrilateral. Okay, so we're next gonna go to the next step, and we're talking about composite shapes. Sometimes a single shape will not tessellate. Okay, so for example, if you take a look at this shape right here, this is an ordinary octagon, right? And if I try to make a tessellation by adding up the interior angles, or just, this is the tracing. If I do the tracing, look what happens. Here's my octagons, but look at the middle here. We have gaps. So an octagon like this does not tessellate. However, if you look at this, what if I put this one right here and this one here together? I glued them together. I would then have the hexagon with a square, the hexagon with a square, the hexagon with a square, right? So I'd end up getting, now you can look at this, there's gaps, so this one does not tessellate. Now, going to the next page, you'll see that what if I took the hexagon and I attached the square to it? Now this line is gone because now it's what's called a composite shape, which means this and this go together to make one shape, right? Now I take this and I draw a pattern with it, and you can see very clearly that this shape here tessellates, no problem. So the octagon that we had does not tessellate, but if I add the proper shape to it, I can make it tessellate. So what I want you to do down below is I want you to create a composite shape polygon that tessellates. Now this may take you a couple of tries, all right? Now you can't do what I did, right? No hexagon, no octagon square, right? So take your best guess or your best try, and in a couple seconds I'll reveal to you what I did. Okay, here are my two shapes. I have a square and I have a triangle. When I put the triangle on top of the square and make it one shape, I get this composite shape right there. Now, this here tessellates, and so does that. But more importantly, this one makes a five-sided figure. It's a pentagon, and it actually tessellates also. Take a look over here. Now, my drawing's not quite lined up perfectly, but you can see very clearly that we have a tessellation easy. Okay. So this shape and this shape, when combined, they also tessellate. Now be careful. That does not mean that they always will tessellate. Okay. There's sometimes when it doesn't, because not all pentagons tessellate. All right. So get on your assignment. If you have any questions, you can come in and see me. If not, we'll correct this probably the next day. Okay? So see you next time.